Tech fans, welcome back once again to Tech of Tomorrow, where today we've got something kind of cool to show you with our guest JJ from ASUS. Now, I don't know if a lot of you guys know about optimization, but now we're going to show you something from these guys, which is 5-way optimization, all software oriented on their mainstream and WS series motherboards for 2014. So, without me talking anymore, let me just hand the floor over to JJ and let him tell you all these great things and how you can optimize your motherboards the absolute most that you've ever been able to do now.
Well, thanks as always, Matt, for having me. I appreciate it. One thing to clarify, though, definitely is that this is a software level functionality in terms of how you interface it within the operating system, but this is hardware based. So this is not a question of just you thinking that it's software overclocking. This is working on, a hardware and firmware level. So there's full interaction. This is actually making full adjustments to the UEFI. Just
what I meant though is that actually from the user's actual interface, it's all software. The users themselves aren't actually going and making any hardware changes. They're doing it all through the UEFI. 100%.
But I think it's also important that we clarify on that too, because I think, we both known that even though we've now shown you guys here at Tech of Tomorrow and in the past in other videos as far as showing you guys our automated overclocking technologies, there's still some people that sometimes might only think that this is just a pure software implementation. And I think it's really important because the complexity of how we have this work and the effectiveness of how it really works really only comes through because of the advanced combination of it being firmware, hardware, and software based. So it's a process of really leveraging all aspects of how the system comes together. So like you were mentioning here, real big focus that we did when we first designed and developed auto tuning, as well as now with 4-way optimization in the Z87 based platform and now 5-way optimization for Z97, is trying to make sure that when a user takes advantage of one of our mainstream series boards or WS series boards, that they're going to have essentially the easiest way to be able to fully take advantage of their system, get it overclocked, get it calibrated in terms of fan speed so that it's cool, it's quiet, it's easily adjustable in terms of all those points, as well as even be able to have more advanced levels of functionality at how they can take performance and even assign it to specific applications.
And all within the Windows environment, though, correct?
All easily. So
that's what I meant when I said by software. Like for the user, they're basically, for them, they're going to be clicking a mouse. For them, it's very, very easy. All the technology, everything, you guys have already done all the hard work. For the user, they're just going to be clicking on the GUI going, oh, wow, cool, that works awesome.
Yeah, no, definitely. It's a very seamless process for the user. So what we've gone ahead and done here is we've opened up the AI Suite 3 system utility. So this is pretty much the same as the last generation. We've gone ahead and overhauled and made some changes here. And what we've gone ahead and done is if I just click back and I go here to this big button that says 5-way optimization, this is pretty much integrating each one of the individual modules like the TPU, the Fan Expert, the Digi Plus, the EPU function, and the Turbo app, but it's all self-contained in one program. So we're just going to go here and you can see right here we have fast tuning, extreme tuning, and we're going to select extreme tuning because extreme tuning is going to allow us to dynamically overclock the system just like a normal user would, where it's going to increase voltages, it's going to increase the multiplier, it's going to make setting adjustments to things like the power VRM and phase response, the phase loading policy, OCP, and a whole bunch of other technical parameters if you were manually overclocking a board inside the UEFI, right? And we're going to do it through the ratio, which means it's just going to increase the multiplier. But if you wanted to do BCLK overclocking, that's also supported. But for this generation, we've taken a lot of the feedback from the community and also from our experience and really evolved how we can go about the auto tuning process. In the past, what we've essentially done is we fixed the maximum target voltage of 1.275. We did that because that was the realistic limit of what probably most cooling solutions on the market could handle. Even though you could maybe put more voltage than that, it really wouldn't make sense because you wouldn't be able to thermally control that level of voltage. So this is us also keeping in mind, hey, we're keeping your guys' safety on your hardware and also relating that to what the real cooling solutions are out there in your ecosystem, right? Now, in addition to that, if we once again reference the older design, it would dynamically overclock the system up to whatever the CPU and your cooling solution, your memory, your power supply, your line level quality from your wall, all those things would allow for. That could be maybe 4.2, it could be 43, it could be 47, it could be 48. It all varies. But the great thing is, exactly, it's specific to your system. But what we've gone ahead and done for this generation is even taken it further to allow for some really cool granularity and control. So you can see right here, we have ratio start from. That means that if I want to start the auto tuning process from a specific frequency, I can go ahead and do that. So instead of it starting from just the pure stock frequency, if I wanted to start from 41 and then just ratchet up from there to shorten maybe the auto tuning process, you could go ahead and do that. Now, if you want to go ahead and even get a little bit more specific, there are some users out there that we've seen in the community that sometimes they buy their hardware, and even let's say if they auto-tune their system and it could do 4.6, they actually don't want 4.6. For some reason, maybe some users feel more comfortable saying, I only want to shoot for 4.2 or 43 or 44.
Because they think it's going to make it last longer.
Right. It's a possibility. Whatever your preference might be, what we've decided to do is be able to give you guys the flexibility to do that. So what you can do now is you can drive towards a specific target frequency. So let's say I only want auto-tuning to go up to 44. Well, I can do that. I can pick 4.4 gigahertz as far as my target frequency, and what auto-tuning will do is it will attempt to dynamically tune up to that. Now, if your CPU and your cooling solution and everything can do up to 44, you'll get to 44. But if let's say it can really only do up to 42 because it hits that that voltage wall, or the CPU margin just isn't good enough to get to that frequency, then it'll only go up to 42. But essentially you can define.
Now, will this tell you if it does that though? If you try to go for a frequency that it won't hit, will it tell you, hey, we're only going to be able to go this far?
Correct, but we won't know that until the end of the process, right? Okay. Because of course it doesn't have any way of knowing what the CPU is. But as it's going through the tuning process, at the end outcome, it's either going to tell you that you've hit that target frequency or that it's only been able to successfully achieve 4.2. But it allows you guys to even have more flexibility at how you want to define your overclocking. But we've even done more than that. For this generation, we've added in temperature target-based overclocking. This is pretty crazy.
So that pretty much means if you only want the thing to go to 47 Celsius, nothing higher, it goes to that point and then throttles down from there?
Correct. For all intents and purposes. That's a pretty
interesting thing, actually.
Yeah. Probably nobody would ever pick such a temperature that low, but most
I know, I'm just giving an example.
Yeah, but for a user, what they might target would be something, let's say, like ADC, right? A lot of overclockers, they set this up and they go, I don't ever want my system to go over ADC. So now what you could do is you could go in there and same thing. If I want to go ahead and set this to ADC, it will only overclock up to ADC. So what it'll do is it actually tracks the temperature as we're doing the overclocking and doing the stress testing, and it's accounting for what the temperature it's running at. And if it gets to the point that it goes over ADC, it says, oh, that's it. Yeah. Not going to go any further. I'm going to stop. So it's not even frequency based, it's temperature based. So
yeah, so what this means, guys, is like basically if your CPU goes to 3.5 and it breaks that threshold, it's going to throttle down. That's right. What it pretty much means.
But if you've got a great cooler, like here we've got this Corsair H110, right? This is going to be really well cooled even at higher frequencies. So this might allow us to get to 47, 47 or maybe 46, right, as far as our multiplier, and still have that be ADC even under full stress tests. But essentially here, you're going to have that flexibility to be able to target in your specific temperature.
Yeah, that gives a lot of flexibility to a different type of user and what they're looking for.
Correct. Now, if you don't want either one of those, it'll fall to the default option, which is, like I said, it's pretty much just going to go to what the maximum that the CPU will allow for, and it will still target, still track the temperature, but we're only going to be accounting for what's called thermal throttle. So essentially, we're just making sure that the CPU temperature never reaches essentially the throttle or the breach point.
So what is pretty much 4.7 is the top target CPU thing that you guys have in this? Is that what it is?
There technically is no limit. It would be the limit would be imposed by the cooling solution and by the voltage that would allow for that frequency. Now, in our experience, 1.275 for the best CPUs will probably realistically be somewhere between 4.8 to 4.9 gigahertz. But the majority of CPUs are probably going to be much closer to maybe 43 to 45, somewhere in that range as far as what they would be able to achieve at 1.275. Because voltage is ultimately what's create heat and what allows you to keep scaling higher.
Exactly. Right. Keeps you stable. Yeah. Up the voltage, baby.
So an additional item that we've added for this generation is something really cool. We've also added full system memory stress testing.
What?
Full system memory stress testing. So the cool thing about this with the memory stress testing is that we can dynamically now stress test memory with also stress testing the CPU. And this is an important consideration because sometimes what happens is that users, when they dynamically overclock their system, they don't realize that the CPU frequency can affect the actual stability of memory. And so sometimes you might have a CPU that can do 4.6 gigahertz, but it can't do 4.6 gigahertz and DDR3 2400. It might only be able to
not at the same time.
Yes, correct. It might only be able to do 4.6 at 2133 at the same time versus at stock, it could do stock frequency and 2400.
Which is true, which is why actually those pro overclockers spend so much time doing it, trying to find that balance between the highest of everything and that means stable.
Exactly. And that's also why actually all the memory kits that you buy, they generally don't test the memory kits at high CPU frequencies. The XMP profiles are always designed to be run at CPU stock frequency versus running it at a high frequency because you can never ensure that memory could run at that speed at a stock value.
But see, you mentioned that XMP profile. So many users still out there don't even engage XMP. They just stick it in their system and go, and then they go and they look, they go, oh, why is my system not running it? That just cracks me up.
And the really cool thing about auto-tuning is auto-tuning will automatically apply your XMP profile for you. So you don't even need to do anything. When you run the actual
dummy proof.
Yes, when you run the auto-tuning process, right here we've got some Corsair Vengeance Pro DDR3 2400 kits. When it goes through the auto-tuning process, once it reboots, it will have automatically set that for us. So not only are we going to get an overclock, but we're also going to have our memory overclocked as well.
Yeah. I mean, I personally think this kind of stuff is great because so many users out there don't really know a whole lot about their system or how to use it. They know they might have bought the absolute best equipment, but with this, you get, honestly, with all this stuff in there, you can pretty much get everything to go as best as you want without having to really tweaking thing that's going to go, oh my God, I just wrecked my system. That's what makes it awesome.
Yeah, and we've also taken into consideration a lot of things that users don't always also realize too. Like we talked about last generation, our voltage policy. Unlike a lot of other options that might be on competitor solutions, when we default our auto overclocking technology, it's using efficient adaptive voltages, which means we're now using like fixed manual vids. So even though we're limiting it to 1.275, that means when your CPU is idle, guess what? The voltage also comes down. We're not always forcing this consistent manual vid, which is going to produce more heat. It's going to actually consume more power, as well as over the long term, it could also produce what's called voltage degradation. So all the way around,
JJ,
we're doing all this stuff for you.
For the overclocker who's like the really extreme guy, like Fugger and all those guys, they can still go in the BIOS and change the voltage to any damn thing they want.
100%.
Right?
Of course, all our boards, whether it's TUF, whether it's ROG, whether it's WS or the mainstream series, all of them have the same class of manual level overclocking capability. So however you want to be able to achieve your results, our goal is to be able to make that happen for you.
Yeah, whether you're an intense guy or whether the guy wants to just lay back and click a button, right?
Correct. So at this point, we rounded things off with, like I said, saying that we added in the memory testing. And one last new option that we've also added in is the ability to go ahead and extend the stress test duration. So in the past, we had a fixed interval of essentially that would run approximately 15 to 20 seconds in between each step increment.
Oh, now you can change it to a longer or shorter increment?
So if a user wants to, if they want to do 1 hour in between each increment where it's running that full system stability test, they can do that. So can
I fall asleep on your shoulder if we're going to do that? Because we're going to be here a while.
Don't worry, we're not going to do that. We're going to keep that at the default. And we actually find that in the majority of cases, especially with the improvements that we've made for this generation with the memory stress testing and even further advancing the actual system stability tests, that probably over 85 to almost 90% of you will find that this will give you full system stability. But for you guys that want to just take it to a little bit more kind of extensive measures and be able to feel a little bit even more confident, you can now go in there and customize it so that if you want to have it go take longer in between each interval, then you can go ahead and do that.
I personally think though, for most people, unless you're out there really, you're trying to break a world record, I think this is just the way to go. It's just so much more easy for the user. You just click a couple buttons, do a couple restarts, get a nice solid overclock. You know your system's not going to be burned up, breaking down, and you get good results. I mean, I think that actually most people are going to choose to go this route.
Well, we've been really happy with it. You know, we invented auto-tuning technology in P55 and we've continually progressed upon it, and we feel it's absolutely the best auto overclocking technology out there. And I actually really challenge it, even guys that are manual based overclockers. In most situations, you're not going to really be able to get more out of the system manually than you would be able to do it in this way. We're doing it effectively, efficiently, and also with great level of scaling that correlates to your hardware.
Well, plus all the testing that goes involved in doing this, like, so you're not a user experimenting. This is actually stuff that's been tried and true methods to actually achieve a result, where a lot of people, if you're new to overclocking, you might go in and click the wrong thing, and the next thing you know, boom, bye-bye CPU. I mean,
no, you're 100% right. I mean, there's definitely safeguards that we put in to protect the users, but at the end of the day, you know, we've put in literally tens of thousands of man hours collectively from our team doing a lot of this work and analysis to make sure that we've got something that's functional, useful, and ultimately beneficial to you. And especially if you're buying a board right at the launch of a chipset cycle, you don't know what the voltage ranges are. You don't know what the parameters to change are.
A card doesn't need a speedometer, but it's sure nice to have one.
Sure. So let's go ahead and just kick this off first. So we're going to go ahead and click the start button, and we're going to go ahead and allow it to go through the auto-tuning process. Alrighty. So at this point, what's going to now happen?
We're auto-tuning.
Yes, we are totally auto-tuning. But auto-tuning in the good way.
Over-tuning. No, it's not going to be a bad rap song, we promise.
Yeah, totally. So what's happening now here is that the operating system has sent that information over to the UEFI, and the UEFI has now acknowledged, okay, I'm ready to go ahead and start dynamically tuning the system. So what it's going to do is going to apply an initial profile overclock to start the actual auto tuning process off. And once now it starts that auto overclocking process in the operating system, it will then begin to dynamically scale everything upwards. So we're going to be increasing the multiplier, we're going to be increasing the voltage, we're going to be tracking the temperature. All these things are going to be happening in real time.
And how many restarts would you say that it actually takes before you get the absolute like best results? Is it a single one, 2 or 3?
It actually, because it depends on your configuration, right? I would say if you were running like the Intel retail fan, you know, and you had a very poor quality CPU in terms of the margin, it could maybe take as little as 1 reboot and it would be done. If you had a great system like ours where we've got a good quality CPU, great quality cooling, good quality power supply, on average I would probably say it maybe takes about 10 to 12 minutes, maybe up to 15 minutes. So it could be probably in the vicinity of maybe 2 to 4 reboots. But probably I'd say average users are probably going to be having the auto tuning process take about 10 to 12 minutes. And it's going to probably be in the target range of probably about 2 to 3 reboots.
Right on. That's still not a whole lot of time either.
Well, when you think about manual overclocking, at a minimum would at least take you a couple of hours, and that's if you probably knew.
Restart,
and that's
restart.
if you knew what you were doing.
Exactly.
For somebody that doesn't know, you probably have to spend hours to research, go into some forums, look at some videos, you know, look at some guides, and try to figure that out.
What does that mean? What does that do?
Right.
I think I'll change it. Oops.
And then you have to reboot, set, go and stress test, find out what's wrong, and keep going through that same exact process. So you can see here, our system has gone ahead and already pre-defaulted to 4.3 gigahertz because we're actually not using an integrated, we're not using a discrete graphics card. The iGPU also got overclocked. So it went ahead and set our XMP profile to 2400. We overclocked to 4.3 and we overclocked the iGPU. Now, if you want to stop at that point, you could, and we could just click stop. But we're now continuing the overclocking process. So you can see right now what's happening is that the fans are revving up because the system is actually under full stress tests. So we're going to open up our task manager right here. And if we start to see, we can already see that, of course, the load occurred, right? It shot up to 100% load. And now we're going to 4.4. Here we can see active cores at 43 still because we're doing the 2-core stress test because you have what's called per core overclocking. Sometimes you can have higher frequencies on 1 and 2 threads versus you having them on 3 and 4 threads. Exactly. So we're checking all this stuff for you. And you can see right here, we're even tracking the temperature and we tell you what the maximum temperature is, and we even subtract the maximum temperature based off of what's called a thermal junction. So you know how close you are to the thermal junction. Directly below that, you can see how much voltage is being applied in real time to your system, and we'll even tell you what the maximum level of voltage is that's applied. But like I said, it will not exceed 1.275 in terms of the voltage. And then lastly, we even show you how much wattage is being taken up because wattage generally correlates to heat, but it also helps you to know how much power consumption increase is occurring on your system as well.
So it covers everything.
So yeah, you're getting everything. So you can see right here, our memory hit up all the way up to 7.8 gigs in terms of active memory usage. Our CPU is pegged up on multiple occasions here up to 100%. And we're throwing all kinds of complex instruction sets to the CPU, just like complex real applications will. So overall, you're getting this full dynamic real-time auto overclocking process that's occurring. And as you can see here, we're now continuing to scale up. We're now at 4.5 gigahertz. And it's going to now just continue to keep tuning. Now, like I said, depending on the
on this particular system that you've been using, JJ, what have you generally seen? I know because I know that eventually it probably does change every so often. But when you reset this to default and then you redo this again, what is the average overclock you're seeing on this particular CPU?
So on our specific system with this CPU and this cooling solution, it's probably going to hit, I would say, probably 4.8 gigahertz.
That's still a pretty damn good overclock.
Yeah, well, I mean, for 4770K, it's probably about the best you could actually see.
Well, I mean, and there's, I mean, this water cooler is a very inexpensive water cooler.
Well,
I mean, considering it's not like going out and buying one of those break-apart systems that cost you $100. That's an all-in system at about 130 bucks.
Yeah, definitely. I mean, it's probably one of the best closed-loop water cooling solutions. But I definitely could tell you, you could probably mimic similar results to this. You know, even with Corsair H80, so the double wide radiator would still give you comparable results. But overall, that's really the big benefit that we're trying to tell you guys, is that the great thing that you have here is, regardless of what parts you're buying, whether it's a $20 cooler, whether it's a $40 cooler, or a $100 closed loop water cooling solution, right? You're going to have a customized result that's specific to your system. And so this just feels ultimately like you're getting really, like you said, I think that's the best way to interpret this.
The dog's very interested in this overclocking thing.
You're getting the best experience possible, right? You're getting ultimately an experience that's tailor-made to the hardware that you you've purchased. So like you said, you can buy some great quality hardware, and even if you don't necessarily know how to fully take advantage of it, or even if you're a veteran like me that's been building and tuning systems for a long time, I feel comfortable. I won't, you know, my system at home, I've got one that sure I manually tweaked and tuned just for my own kind of insight and edification, but I've also got a system I totally let auto tuning do its job because I felt confident in what it was giving me, because it was efficient, it was effective, and it overclocked it very competently. You know,
Ever since the beginning, when these programs first started coming out, I've always actually liked them quite a bit, because going in there and tweaking a bunch of stuff, I mean, it's cool if you're really, you know, just trying to push things to the limit. But if you're trying to just get some really solid results without having to give yourself a headache, this is just always the way to go.
Yeah, well, if it works, right? And I think both of us have been in the game a long time, that we remember that, you know, way back when first generation auto overclocking technologies weren't really that reliable, they weren't that stable, and they weren't effective.
But I mean, by that point, though, a lot of times back then, like Intel and other companies didn't really embrace overclocking as much as they do now either. So now, like, even the companies themselves are like, oh, okay, we're gung-ho for overclocking. Where in the past, they were kind of like, oh, overclocking. So I think it's made, I think it's made it easier too for everybody.
Yeah, I mean, overall, you know, there's always been different kind of perspectives at how overclocking has been evaluated and been embraced. But, you know, our goal is ultimately, regardless of how you guys are integrating or considering your systems, we just want to give you the flexibility. So we can see right here, we're probably about to get at the top end, and the system's actually going to probably get ready to crash. So we can see we've gotten to 4.9 gigahertz now on
it's not going to burn, is it?
No. It's gotten to 4.9 gigahertz on 1 and 2 cores, and 4.8 gigahertz on 3 and 4 cores.
Right on.
Right? Eventually, though, we're going to hit a wall where the voltage that we have supplied, or the CPU margin, or the cooling isn't going to allow. There's going to be one that will cause an issue. At that point, the system essentially is going to acknowledge that fact, because it's going to register the crash.
I think because you're here with us, it's just going to hit 5.0.
No, I don't think so. So you can see right now
5.9, folks. What do you think? You know, 7.0. I mean, what the heck? We're going for the extreme overclock, you know?
So at this point, once it goes ahead and finishes up, it'll reboot, and then it'll finish out and provide us its results.
Still going, though.
Well, we'll see. But I don't think it's going to go.
Oh, 5.0, folks. What did I tell you? See, here at Tech and Tomorrow, we take that shit just a little bit further.
Okay.
Oh, so it ran to a restart.
Yeah, so I can see. Now, it might be actually, your house is fairly warm. So I'm surprised it got to that, because sometimes in a cooler temperature, it might get to that level, right? Because like I said, it's system specific, right? But now what's going to happen is that the system is going to realize the fact, hey, I got to a point that there was too much instability, and it's going to go back, and it's essentially going to revert to settings.
So whatever one we get now, though, is the one that it is, right?
Yes. So what it's going to do now is it won't continue the auto tuning process. It's essentially going to go, I've reached that maximum result. Now what I need to do is roll back to actually the last very verified stable settings, and give you that setting as your default auto overclock. So it's now going to come up here in a moment, and then actually after that,
waiting.
After that, it will then progress to the second portion, which will be the automatic fan tuning process. So we'll then calibrate all of our fans that we have in our system, allowing us to go ahead and make sure that every single fan, we figured out the minimum and maximum. So we can see right here, it's moved straight into the fan expert. We're tuning every single one of the fans. All you see, all the fans have ramped up really high, but they're also now going to ramp all the way down to effective 0 RPM. So they're going to be pure silent. And the reason why is every single one of these headers is going to be manually defined, so that we know, regardless of what type of fan you have on there, we know what its minimum and maximum operation is. Now, the really cool thing that we're not showing here, but definitely, you know, make sure to check out more information that you're going to see here on the Tech and Tomorrow channel, is that these motherboards for this generation, we've given the ability to have full DC and PWM output control for every single header. So not only can we control every single type of fan that you connect to this motherboard, but we can set to control it in the most unique and configurable ways possible.
And just adding a splitter, you could add even more fans.
So that's the awesome part. So like in this Corsair chassis with the side panel and having actually additional fans that can be mounted there, the motherboard only has 6 fan headers, but having that ability to set it to PWM, like I said, and you noted, you can go ahead and plug in your PWM splitter, run 3 more fans to that, and they can be powered by the power supply, but they can be all controlled by the motherboard.
Yeah, exactly.
So a really awesome level of control and flexibility that also for this generation, we've given you the ability to map multiple temperature inputs to different headers. So you can map to chassis fan header, the VRM temperature, or the PCH, or even on some of our boards, an optional temp sensors on the motherboard to allow you to run
okay, so then you could increase the RPM in that particular area to cool that area down more.
For whatever position that you put that optional temp sensor, so on the back of your GPU or on top of your SSD, whatever it might be. So we can see here, it's gone ahead and actually finished the effective overclock.
4.8.
4.8 gigahertz. DDR3 2400. It's gone ahead and fully calibrated all of our fans, and it's gone ahead and given us that complete 5-way optimization. So I think some pretty impressive.
Come on, 4.8 from a program where you're hitting a button, it's totally stable. That's really actually quite amazing.
So we're just going to go ahead and ADA64 here to confirm that our XMP has gone ahead and also been applied. And so we can see right here, you can see right there, DDR3 2400, it's gone ahead and automatically set the timings, the voltage, the frequency. And this is the kicker. Look at the efficiency. We have all the C states enabled. We have the adaptive voltage policy. So when the system is idle, guess what? It's dropping down to that lowest CPU frequency, and it's dropping down to the lowest voltage so that we get that best balance of not only high speed, high performance, but great efficiency and low power consumption.
Quiet and cool.
And even for those fan controls, after the fan calibration, we've gone ahead and integrated a great new option here for this generation where we can go ahead and click easy profiles to dynamically change your fan profiles. So you can go ahead and go from silent to full speed if you want. You don't even need to jump into the full program. So the last portion that we just want to show right here is going to be the app tuning portion. So after you've already gone ahead and completed your auto overclock, well, guess what? We're giving you the ability to do application-specific overclocking and profiling.
Now, what this means, folks, that means that you can launch a certain application and you can have all the settings geared for that particular application. You can set it for single core, all the way perked up, multi-core perked up, however you want to do it, right?
Yes, it's totally for me. When we realized giving you this flexibility, I was totally like, okay, mind blown. I was like totally surprised by this level of functionality. And just to quickly show you what it would be an example is, let's say you did it for a game. We're opening up Marvel Heroes here, but it could be Battlefield 4. You could go ahead and refresh the tab. You click over into this, and let's say you know that that game utilizes all those cores. Well, you want to set it to the maximum frequency that could be advantageous, because let's say if you jumped into Adobe Lightroom, well, Lightroom is more maybe single-threaded.
Right. So well, I don't want to interrupt you, but one thing you folks might want to do is you might want to go out and do some research on your program and find out, how it runs best, because then that'll lead you to the road of how to set this up correctly.
Correct, because some applications are going to be more so than others. But the advantage of this is with per core overclocking. Maybe you want to go ahead and have one program running at 4.8 gigahertz on a single thread, where your CPU can't do 4.8 on all cores, but for the other application can do more frequency across all cores. So, Premiere could do 4.6 on all cores, and then Lightroom could do 4.8 on a single thread. And then lastly, what we can also go ahead and adjust is audio. We can go ahead and customize it so that you can go ahead and automatically set a specific audio preset to that application that will change automatically, as well as the LAN prioritization. So once again, if we have Marvel Heroes, it's a game, we would want the audio to automatically set to the game preset.
Exactly.
And then the LAN, we would want it to have high, because since it's an online game, we want the lowest ping
make sure you can get
and
those
lowest latency.
Yep.
Exactly. And that will all happen dynamically, so that you can go ahead and map this to as many programs as you want and be able to have this dynamic system-specific overclock and presets run. So some pretty awesome functionality that we've introduced here with 5-way optimization.
It's amazing stuff. So there you guys have it, folks. Never has optimization been easier. So if you want to have your system be, as flexed out as you want it to be, hey, it'll do it here automatically for you without a headache. For those of you guys out there who are like the extreme overclocker guys, we know that you're not going to be using this. But for people out there who are new to this and who want to take their time and work their way into doing that, this is the absolute best stepping stone I think that you're going to be able to get.
Yeah, it's awesome, man. I'd love to see your guys' comments. I'll definitely follow up and respond into the comment section, but I definitely love to hear what your guys' feedback is on what we've done for this generation of 5-way optimization. So as always, thank you guys.
So let us hear your comments down below. Like we said, all the information about this will be down there below, like button in the description. I'm Elric with Tech of Tomorrow. This is JJ from ASUS. Thanks for watching Tech of Tomorrow. We'll see you guys back here for more videos very soon.